The National Electrical Code, specifically Article 500, addresses hazardous classified locations. There are no specific prohibitions in the NEC against using battery-operated clocks in Class 1, Division 2 hazardous locations. The National Electrical Code, Chapter 5, Special Occupancies, Article 500 Hazardous Classified Locations, Section 500.8. B1. The Roman 2 states, unless specifically approved for the class, group, and division of location, equipment shall not be installed unless the internal compartments are filled with a suitable compound or are adequately ventilated to prevent the accumulation of flammable vapors or dust, and the external surfaces are protected against the entrance of flammable vapors or dust. Battery-operated clocks typically have sealed compartments and do not pose a risk of accumulating flammable vapors or dust. Therefore, they are generally considered safe to use in Class 1, Division 2 hazardous locations. However, it is important to always consult with the equipment manufacturer's instructions and specifications. Ensure that the clocks are not used near potential ignition sources such as hot surfaces or open flames. It is also important to regularly inspect and maintain the clocks to ensure they are in good working order and to replace batteries promptly to prevent any potential issues. In conclusion, based on the available information, it is generally acceptable to use single-double battery-operated clocks in Class 1, Division 2 hazardous locations. However, it is important to carefully consider the specific equipment and environmental conditions and always follow the manufacturer's instructions and safety guidelines. When considering electrical equipment for hazardous locations like a Class 1 Division 2 chemical plant, several factors must be taken into account to ensure safety and compliance with the National Electrical Code, or NEC. Class 1 locations are those where flammable gases or vapors are, or may be, present in the air in quantities sufficient to produce explosive or ignitable mixtures. Division 2 indicates that the hazardous material is not normally present in explosive concentrations, but may be present accidentally. Now, battery-operated devices, such as single-double battery clocks, introduce a unique set of considerations. While the NEC doesn't explicitly prohibit their use, it's crucial to understand the underlying principles and requirements for equipment in such environments. The primary concern in hazardous locations is preventing ignition. Electrical equipment can ignite flammable substances through arcs, sparks, or hot surfaces. Therefore, equipment used in these areas must be designed to minimize these risks. The NEC provides guidelines on acceptable protection techniques, which include explosion-proof enclosures, intrinsic safety, and other methods. Explosion-proof enclosures are designed to contain an internal explosion and prevent it from propagating to the surrounding atmosphere. Intrinsically safe circuits limit the energy available to a level that is insufficient to cause ignition even under fault conditions. Now let's consider the specific case of a single-double battery-operated clock. These devices typically have very low power consumption and are housed in a sealed plastic enclosure. The risk of sparking or creating a hot surface is generally low. However, several factors should still be evaluated. Firstly, the battery itself can be a source of ignition if it fails or is short-circuited. Batteries can release flammable gases, such as hydrogen, under certain conditions. Secondly, the clock's electronic components, such as the circuit board and motor, could potentially generate sparks or heat. Thirdly, the enclosure of the clock must be adequate to prevent the ingress of flammable vapors or dust, even if it's not explosion-proof. To determine whether a particular battery-operated clock is suitable for use in a Class 1 Division 2 location, several steps should be taken. 1. Consult the equipment manufacturer's documentation. The manufacturer should provide information on the clock's suitability for use in hazardous locations, including any certifications or approvals it may have. 2. Assess the clock's design and construction. Look for features that minimize the risk of ignition, such as sealed components, current-limiting devices, and robust enclosures. 3. Consider the specific characteristics of the hazardous material present in the location. Different flammable substances have different ignition energies and explosion characteristics. The clock's design should be appropriate for the specific hazard. 4. Consult with a qualified electrical inspector or engineer. They can provide expert guidance on the suitability of the clock for the intended application and ensure compliance with all applicable codes and standards. In many cases, it may be necessary to use a clock that is specifically designed and certified for use in hazardous locations. These clocks typically have explosion-proof enclosures or intrinsically safe circuits. They are tested and approved by recognized testing laboratories such as Underwriters Laboratories, or Factory Mutual, or FM, to ensure that they meet the stringent requirements for use in hazardous environment. Even if a battery-operated clock is deemed suitable for use in a Class 1 Division 2 location, it's important to follow certain precautions to minimize the risk of ignition. Firstly, always use the correct type and size of battery specified by the manufacturer. Secondly, inspect the clock and battery regularly for any signs of damage or deterioration. Thirdly, replace the battery promptly when it is discharged. Fourthly, do not attempt to modify or repair the clock yourself. Fifthly, ensure that the clock is properly grounded, if required. Finally, keep the clock clean and free from dust and debris. In addition to the NEC, other standards and regulations may also apply to the use of electrical equipment in hazardous locations. For example, the National Fire Protection Association, or NFPA, publishes several standards related to hazardous locations, including NFPA 496, Standard for Purged and Pressurized Enclosures for Electrical Equipment, and NFPA 497, Recommended Practice for the Classification of Flammable Liquids, Gases, or Vapors and of Hazardous Locations for Electrical Installations in Chemical Process Areas. These standards provide detailed guidance on the design, installation, and maintenance of electrical equipment in hazardous locations. It's important to be familiar with all applicable codes and standards to ensure that electrical equipment is used safely and in compliance with regulations. Understanding the NEC requirements for Class 1 Division 2 locations is crucial for ensuring safety in chemical plants and other hazardous environments. While the NEC doesn't explicitly prohibit the use of battery-operated clocks, it's essential to evaluate the specific clock's design, construction, and application to minimize the risk of ignition. Consulting with qualified professionals and following established safety practices are essential steps in this process. Let's delve a bit deeper into the technical aspects of evaluating a battery-operated clock for use in a Class 1 Division 2 environment. We need to consider several factors related to its potential as an ignition source. Firstly, let's talk about energy levels. The primary concern is whether the clock circuitry or battery can release enough energy to ignite a flammable gas or vapor. The minimum ignition energy, or MI, of a substance is the smallest amount of energy required to ignite it. This value varies depending on the specific substance and its concentration in air. Class 1 locations are further subdivided into groups A, B, C, and D, based on the specific flammable substances that may be present. Each group has a different MIE. For example, Group O includes atmospheres containing acetylene, which has a very low MIE. Group D includes atmospheres containing gasoline, hexane, and other common solvents. The NEC requires that electrical equipment used in Class 1 locations be suitable for the specific group of flammable substances that may be present. Intrinsically safe circuits are designed to limit the energy available to a level below the MIE of the flammable substance. This is achieved by using components with low voltage and current ratings and by incorporating current-limiting resistors and other safety devices. The design of intrinsically safe circuits is complex and requires careful analysis to ensure that the energy levels remain below the safe threshold even under fault conditions. Another important consideration is surface temperature. Electrical equipment can ignite flammable substances if its surface temperature exceeds the auto-ignition temperature, or AIT, of the substance. The AIT is the temperature at which a substance will spontaneously ignite in air. Like MI, AIT varies depending on the specific substance. The NEC requires that electrical equipment used in Class 1 locations be marked with its maximum surface temperature. This marking allows users to select equipment that is suitable for the specific flammable substances that may be present. The enclosure of the battery-operated clock also plays a crucial role in preventing ignition. The enclosure must be designed to prevent the ingress of flammable vapors or dust. This is typically achieved by using a gasketed enclosure that is sealed to prevent the entry of outside air. The enclosure must also be strong enough to withstand the pressure of an internal explosion without rupturing. Explosion-proof enclosures are designed to contain an internal explosion and prevent it from propagating to the surrounding atmosphere. These enclosures are typically made of heavy-duty metal and have threaded joints or other special features to ensure a tight seal. The design of explosion-proof enclosures is governed by strict standards, such as UL 1203, standard for explosion-proof electrical equipment for use in hazardous classified locations. Now let's consider the specific components of a battery-operated clock. The battery itself is a potential source of ignition. Batteries can release flammable gases, such as hydrogen, under certain conditions such as overcharging or short-circuiting. The clock circuitry, including the circuit board, motor, and other electronic components, can also generate sparks or heat. The risk of ignition depends on the design and construction of these components. Some clocks may incorporate features to minimize the risk of ignition, such as current-limiting devices, sealed components, and robust enclosures. In addition to these technical considerations, it's also important to consider the human factors involved in using battery-operated clocks in hazardous locations. Users should be properly trained on the hazards of working in these environments and on the proper procedures for installing, operating, and maintaining electrical equipment. Regular inspections and maintenance are essential to ensure that the clocks are in good working order and that any potential hazards are identified and addressed promptly. The batteries should be replaced regularly, and the clock should be cleaned to remove any dust or debris that could accumulate and create a fire hazard. Furthermore, it's important to remember that even if a battery-operated clock is deemed suitable for use in a Class 1 Division 2 location, it's still possible for an ignition to occur. No electrical equipment is completely immune to the risk of ignition. Therefore, it's essential to take all reasonable precautions to minimize the risk of fire or explosion. This includes following all applicable codes and standards, using properly designed and maintained equipment, and training personnel on safe work practices. When evaluating a battery-operated clock for use in a Class 1 Division 2 location, it's also important to consider the specific requirements of the local authority having jurisdiction, or OJ. The AHA is the entity responsible for enforcing the NEC and other applicable codes and standards. The AHA may have additional requirements or restrictions on the use of electrical equipment in hazardous locations. It's important to consult with the AHA to ensure that the clock meets all applicable requirements. Ultimately, the decision of whether or not to use a battery-operated clock in a Class 1 Division 2 location is a complex one that requires careful consideration of all relevant factors. There is no simple answer that applies to all situations. The best approach is to consult with qualified professionals, follow established safety practices, and err on the side of caution. Electrical safety in hazardous locations is not just a matter of complying with codes and standards. It's a matter of protecting human lives and preventing catastrophic accidents. Therefore, it's essential to take this issue seriously and to do everything possible to ensure that electrical equipment is used safely and responsibly. Keep in mind the group classification for the environment. The group classification, as previously mentioned, dictates the type of hazardous material present and its properties, which directly influences the selection of suitable equipment. Ensure that any equipment selected is certified for the specific group designation applicable to the chemical plant's environment. For example, if the plant handles acetylene, equipment certified for Group A would be required. In summary, while the NEC doesn't explicitly forbid battery-operated clocks in Class 1 Division 2 areas, a thorough risk assessment is necessary. This assessment should encompass factors like the clock's design, potential ignition sources, compliance with safety standards such as those from UL or FM, and adherence to manufacturer's instructions. Consulting with an experienced electrical engineer or certified safety professional is highly recommended to ensure compliance and minimize the risk of accidents in a chemical plant. Also, document all assessments and decisions made regarding equipment selection for hazardous locations. This documentation serves as evidence of due diligence and can be invaluable during audits or inspections. Regularly review and update these assessments to reflect any changes in the plant's processes or environment. Remember, safety is a continuous process, and proactive measures are essential to maintaining a safe working environment in hazardous locations. This is a continuous process for maintaining a safe working environment. By taking a comprehensive approach and addressing all potential risks, you can help ensure the safety of personnel and prevent accidents in the chemical plant.